Okay, hello everybody. Today we're going to talk about the third topic, the third lab sheet that we have to deal with for this module. We will be doing some routing. So today we're on the week of the 10th to 16th of October, and all of the material about this lecture and everything that we'll do is on the week of the 21st of November, which is the routing lab sheet, which is the second to last before DNS. So all of the files that we need are in here. This topic is available. If you just expand it, you should be able to just see it. Okay, so let's have a look at what we need to do. So in the previous lab sheet, which was a virtual network, we were tasked with actually building all of the virtual machines that would make up our virtual network in our computer. So essentially, each and every one of you will have a tiny little virtual network inside their computer. So this basically is running on 4 different networks. So we have subnet 28 that connects your Prometheus virtual machine to the outside world. We have subnets 30, 31, and 32. Now, after you've built all of these, then you should only be able to ping your neighboring virtual machines because you will not be able to go across multiple different networks, across multiple different subnets. So what we're doing is we are going to implement some routing. So we're going to turn our Prometheus host and our vPrometheus 1 virtual machine into software routers. In order to do this, we use a software called Quagga, which is basically a routing program, a routing daemon as we call it. And we will use OSPF as our routing protocol of choice in this particular case. So how do we go about setting all this up? Yes, and before that it was actually Ziba, so they have a thing about animals, so yes. So the network structure that we have. So first of all, you will need to install it on Prometheus itself. Once we get that one working, then that will give internet access to virtual machines 0 and 1. And once that's done, then we'll set up again routing with Quagga and OSPF on virtual machine 1, and that will give internet access to virtual machine 2 as well. Now, for the installation of this, first step is you need to make sure that your internet access is working correctly on Prometheus. So a simple ping google.com should basically do it, because that means 2 things. It means that your networking is working to the outside world. So you have routing, your default gateway to the outside world is actually working correctly. And also that your DNS resolution is working correctly. So it means that your Prometheus should have full internet access to the outside world. It should, because don't forget that your Prometheus virtual machine is bridged on subnet 28, same as the host. So it should simply be able to go out through its default gateway of 28.254 and have internet access through the DNS server that serves the entire lab as well. Once you're able to do that, then you can run YAM installations. So you can use YAM and install Quagga. So simply YAM install Quagga in a terminal as root. Always remember, when you log into Prometheus, will basically let you download the software and all of its dependencies and install correctly. Once you do that, then you need to go to Moodle and download the contents of the folder called routing tools. In order for Quagga to work correctly, we need to have 2 main configuration files, which are zebra.conf and ospfd.conf. Zebra.conf will basically configure the routing daemon, the routing software that does it, which is Quagga. And ospfd.conf will configure the routing protocol that we want to use in order to do our routing. In this case, it will be OSPF. So if we go back to Moodle, we can go to routing tools and we can look at zebra.conf. And it will look something like this. Let's see if I can make it. Yes. So zebra.conf has one purpose in life. It needs to tell the router, so the software that is running on your computer, which network cards we're doing our routing on. So which network cards are involved in the routing process. In our case, and this should be the same for all of you, So zebra.conf doesn't actually need editing, other than perhaps even the host name. No, the host name will be Prometheus for all of you. It doesn't need any editing. You can use it exactly as it is. So we're doing our routing through interface ENS33, which takes you to the outside world, which connects you from Prometheus to your host to the outside world. So this is the bridge itself. And then we have interfaces VMnet 0 and VMnet 1, which, according to our network diagram, are the network cards that connect you to the inside of your network, that connect to virtual machine 0 and virtual machine 1 and beyond. So remember, we're working on Prometheus now. Okay, so the zebra.conf for this machine will be as it is exactly on the example. So you don't actually need to make any changes for it. Once you download it and you save it in etc. Quagga, then you need to download the second file, which is ospfd.conf. And this one will require a bit more effort on your part. So the purpose in life of this particular file is to tell everybody around you who you are and which networks you're sharing to the outside world around. So in our case, this example was created for my computer. Okay, so I am working on 148.197.28.111. So this is the IP address of my ENS33 network card on Prometheus itself. So this is my bridge to the outside world. I then have the networks that are directly connected onto the network cards that are involved in routing. So if you remember from zebra.conf from before, we had ENS33, which takes me to subnet 28, and we had VMnet 0 and VMnet 1. So VMnet 0 is my network 30, and VMnet 1 is my network 31. So I will need to have network 28.0. So this statement will actually be the same for all of you because you're all working on 28.0, the class C network that you're working on, because your ENS33 network cards belong to the bridge. And then we have my networks 30 and 31. When I say my networks, I mean the networks that specifically belong to my computer. So this you will definitely need to change because each of you has a different network address depending on the network that belongs to your own computer according to the subnets file. So if we go back to the module, and if we go to virtual network, we're looking at the A2.NET subnets. So according to this, depending on which computer you are working on, this is the network address that is allocated to you. So if you're sitting on Betel, then this file should have 30.48 and then 31.48. Okay, so this file will take the network address for your subnets 30 something and 31 something. There is also a statement here for network 32. However, we don't need this yet because network 32 is not directly attached onto your router. Yes, it is a network that belongs to you, but you use it on vPrometheus 1 and 2. So it's not directly connected onto this one, so you don't need to mention it. Remember, OSPF works by telling all of the neighbors what it knows. So this computer only knows about networks 28, 30, and 31. Once routing works here, then this and routing eventually works on this one. This computer will tell Prometheus that, look, I also have network 32, and you can get to it through this network card. All right, so what we need in our ospfd.conf is hostname Prometheus will stay the same for everybody. You don't need to change the password. You need your router ID, so you need the IP address of the network card ENS33 on your Prometheus, which will be your bridged network card on your Prometheus. And then you need to declare the three networks that are directly connected onto Prometheus itself. So network 28.0, which will be the same for everybody, and then networks 30 and 31, with the network address that corresponds to your own computer according to the subnets file here. Now, once you configure this file as well, both zebra.conf and ospfd.conf will need to save it in etc. Quagga directory. Next step is you disable the bridge on VMnet 0 by typing the command ps-ef pipe grep vmnet. So VMware runs the VMnet network cards. Okay, by default, the system itself will create a bridge on VMnet 0 because it considers it to be VMnet 0 is by default the bridged interface for VMware. Okay, so VMnet 0 is a bridge, VMnet 1 is host only, and VMnet 8 is not. So these are the networking capabilities of VMware itself. Because we don't use this, because we've created our own custom script, then we need to kill this bridge so that it doesn't interfere with our routing process. Once you kill this process, so you run a kill -9 and then the process ID, so it's going to be a 4 or 5 digit number that you get out of this command. You have cleaned your network a little bit by removing the process for the bridge VMnet 0. And next, an important step is that you disable your firewall. So you simply need to clear your IP tables by typing the command iptables -F. Okay, and you need to do this every time you restart your Prometheus virtual machine or every time you restart your networking on it. And then finally, you need to enable packet forwarding by using the command sbin systemctl net IPv4 forward = 1. So this will enable packet forwarding on your Linux host. Packet forwarding is disabled by default on any Linux installation as a safety precaution. Okay, so you download the two files, edit them, save them in etc. Quagga, you kill the bridge, you disable the firewall, you enable packet forwarding. Once you have done this, you're then ready to try out and see what actually happens. So on Prometheus itself, I would recommend you use 4 terminals or 1 terminal with 4 tabs inside it. And on terminal 1, you run zebra -f etc. quagga zebra.conf. So that will run the zebra or Quagga routing daemon in debug mode in a terminal. The result of this is that the process will run. It will show you nothing, no feedback on the terminal, but it will take over the terminal. So it will not come back with a prompt that allows you to type any commands. Okay, so once that is running, then the window is pretty much disabled. You cannot type anything else on it. So you go to another terminal and you type ospfd -f etc. quagga ospfd.conf. Once you type this, things will start happening. So basically, once the routing protocol runs together with the routing daemon, Zebra, then you should be able to see in this terminal all of the network address exchanges between your now active router and all of the routers available that router can access, everybody else in the network. So you should be able to see network addresses being scrolled down and network updates for your routing table. To see your routing table, you go on a third terminal and you type watch root -n. This will also take over the terminal. You won't be able to run anything else in it, but it will show you a live updating routing table for your computer, for your router. So in the beginning, you should see only the few routes that are local to your computer, including networks 28, 30, and 31. However, once routing starts working and once the routing protocol starts communicating with all of the routers around it, after a few seconds, because it does need a while to get all the information from all the neighbors, you will start seeing everybody else's network addresses around you. So all of the other routers that are basically active and running around you. So this will be a first verification that your routing is actually working correctly on your host. Okay, and you have configured your network cards and your routing protocol correctly. The final test will actually be to try pinging from VP0 to Prometheus and then to VP1. So now we're talking about pinging from 0 to the host, which you should always be able to do, but now you should be able to also ping vPrometheus 1. Okay, if you can do this, it means that you're pinging from network 30 to network 31. So it means that you have crossed networks. And to cross networks, it means that your routing is actually working on your host. Now, once this is done, you will now have internet access on vPrometheus 1. So this means that you can do yum install Quagga on vPrometheus 1 as well. So you repeat the process exactly as it was before, and you set up routing with ZBRN SPF on vPrometheus 1 as well. Once you do this, you will be able to ping from vPrometheus 2, which is the far end of your network, to vPrometheus 1, to Prometheus, to vPrometheus 0. So once routing is running both on Prometheus and on V1, then everybody here should have access to everybody else. Furthermore, if you configured your DNS setting correctly here, so in the network card settings, in the DNS tab, if you configured your DNS server correctly, then you should now have full internet access for all of your virtual machines. So they should be able to ping the outside world completely. Okay. Final testing. So after you've set all this up, now your services are running in what we call debug mode. So those 4 terminal windows that are running on Prometheus and vPrometheus 1 mean that the service is running in debug mode. So it's running in a terminal and you have to start it manually every time. Now, once you're certain that everything works, I want you to stop the services. So I want you to stop the terminals. So you can do Control-C inside the terminal to stop them from running, to kill the processes essentially. And you can type systemctl restart zebra.service ospfd.service. So that will basically start the services properly on the computer running in the background as services and not in debug mode on the terminals. And then you can also do check config zebra on and check config ospfd on. This will automatically start the services every time you start your computer, every time you start your virtual machines, and they will be running in the background without you having to start them every time. Okay, so this means that next time you come into class, your services will be running. Of course, you need to type IP tables by yourself again. You won't need to say enable packet forwarding because that was permanent as well. So all you need to do is clear your IP tables every time you restart the virtual machines, and routing should be working. Okay, so once you've done that, then the lab sheet is essentially finished. However, if you do want to get some extra marks and you want to deal a little bit with nothing, with network address translation, you can do this. You can clone vPrometheus 2, which is the machine at the end, and you can assign VMnet3 to it, the custom network card that is created because the list of VMnets will be VMnet 0 to VMnet 8. So let's say that we want to use VMnet 3. You will then need to add VMnet 3 to Prometheus. So I need to correct this actually, and I will by the time we go into the lab. So you need to add VMnet 3 to Prometheus, and you add it to Prometheus by going to that VM subnet file and adding it in there. So if I go to the virtual network and if I look at this file, we have VMnet 0 with IP addresses, VMnet 1 with its IP addresses, VMnet 2 running simply as a process, and then we can have VMnet 3 as well. So in last week, I told you that you don't need VMnet 3 by default, so you can remove this. So if you want to do the optional task, you can actually copy all of this, paste it and rename it to VMnet 3. So that way you will add VMnet 3 onto basically the host itself, onto Prometheus itself. So once you do that, you will have VMnet 3 on Prometheus, and you can NAT it behind the Prometheus 3. So now you need to configure NATing. So there is an example of it on Moodle. So if we go back to our course, and if we go back to the routing folder, there's a file here called nat, and there is a command here that you can use in order to set up natting on the virtual machine that you want to set it up on. Okay. So with that command, you need to mention the network cards correctly. So the network card here, ENS33, will need to be changed. And here you need to have the correct network card or the correct IP address for the network card that you're working on. Then that should give you NATed access to the virtual machine 3, to the Prometheus 2 actually, as you want it to be. Okay. Don't worry too much about this first though. Okay. Go through all of the routing tasks and everything else. And once you get that working and you have some time, I will probably explain this in class as well a little bit more so that you can try and tackle it in class. Okay. So this is the routing lab sheet. Do you have any questions at all about this? What is Quandal Dingle? And what is Amugus? Are you spamming my chat? Right. Okay. Any questions? All right, I will stop the recording.